Okay. Yesterday I was speaking about polarization and that it's happening to the atmosphere. So I said I'd try and figure out what's going on. So I pulled up a couple of pieces and we'll give it a go. And it kind of makes sense, along with biblical references, of what should happen. So okay, this is the first page on polarization, and it tells you what happens between atoms and molecules and electrically charged bodies and species, ions and polar molecules with dipole movements. Now I've gone straight to the factors that influence polarizability, because it's to do with the universal voltage drop and our atmosphere. So we know the atmosphere is collapsing. The EM field is shrinking. So what this means is, as it says in number 1 there, the greater number of electrons, the less control the nuclear charge has on charge distribution, and thus the increased polarizability of the atom. So basically we're squashing atoms and electrons as the EM field shrinks, is pushing down on all the atoms, and so there is a greater number of atoms. Number 2, the greater the distance of electrons from the nuclear charge, the less control of the nuclear charge has on the charge distribution, and thus the increased polarizability of the atom. So everything is increasing. So if the distance of the electron from the nuclear charge increases, so will the polarizability of the atom. And with the universal voltage drop, the electrons will start moving further away from the nuclear charge due to it being less. And so more increase in polarization. And we've got number 3. This was a little difficult to explain. Molecular orientation with respect to an electric field can affect polarizability, labeled orientation dependent, except for molecules that are tetrahedral, octahedral, or isosahedral, labeled orientation independent. This factor is more important for unsaturated molecules that contain areas of electron-dense regions such as 2,4-hexadiene. Greatest polarizability in these molecules is achieved when the electric field is applied parallel to the molecule rather than perpendicular to the molecule. And as I showed in some sundog pictures yesterday, there is a parallel line going across the sky rather than perpendicular. I don't know if that's correct, but I'm believing that our electric field in our atmosphere is changing due to a voltage drop. Now you can read all that dispersion forces piece if you want, but I want to get the polarizability affects dispersion forces in the following ways. As polarizability increases, dispersion forces also become stronger. Thus, molecules attract one another more vigorously, and melting and boiling points of covalent substances increase with larger molecular mass. Polarizability also affects dispersion forces through the molecular shape of the affected molecules. Elongated molecules have electrons that are easily moved, increasing their polarizability, and thus strengthening the dispersion forces. So basically, the more polarization that goes on, the more dispersion forces it have. So it just increases, and you get more vigorous melting and boiling points. So it's starting to heat up, basically. So, having said that, let's introduce you all to atmospheric extinction. Now, it could be as bad as it sounds, but it's not right now. The term extinction means the loss of light in the atmosphere from a directly transmitted beam. So basically, we're losing light all the time due to what's in the atmosphere. And if we look at the reddening part there, because the extinction is generally longer at short blue wavelengths, the setting sun is usually so dim as the wavelengths to be lost in the scattering of light at the foreground. And remain transmitting light appears red. So here's what you have to understand. It's going to get redder, is what this says. If we look down at the scattering and the Rayleigh scattering, if we read the bottom line there, a feature of Rayleigh's theory is often forgotten in the intensity of the scattering demands on the refractive index of the scattering medium, because the refractivity of air is dispersive. The actual intensity of Rayleigh's scattering in air is somewhat steeper than an inverse fourth power law and amounts to an inverse 4.8 power law across the visible spectrum. But here's the line you need. This wavelength dependence is responsible for the reddening of clear air. So things are going to get red. Here's the crazy part though. Why are they spraying aerosols in the sky? Let's have a look at aerosol scattering, and this is to do with the atmospheric extinction again. Atmospheric aerosol is very diverse. Tiny grains of mineral dust stirred up from the ground, particles evaporate, bacteria, pollen grains, mold spores, and other biosol particles. Now if we continue reading there, it says, as most of these are produced at or near ground level and are washed out of the atmosphere by condensation of cloud droplets on them, followed by precipitation, the aerosols all tend to be concentrated in the lowest part of the atmosphere. An exponential distribution with a scale height of about 1.5 kilometers is a rough approximation of their distribution. So we're all sat in the aerosols that are being sprayed in the air, and what it's doing is it's causing refraction, then it's heating up and causing dispersion, and then it's just exponentially increasing. So we go to the third paragraph and read, most of the aerosol particles are so weakly absorbing that their extinction is almost entirely due to scattering rather than absorption. However, carbon particles are quite strong absorbers, and a considerable part of their reddening is due to the increase of their absorption at short wavelengths. So what does that all mean? Basically it means our atmosphere is collapsing, so polarization is increasing, which means heat will increase, which will also disperse the light in a more diverse way, which will cause reddening of the sky. And that's about it, really. So climate change, all to do with EM forces failing, reddening of the sky, all to do with the universal voltage drop, energy levels falling, causing polarization due to a condensed atmosphere. So I suppose Acts 2:20, the sun will be turned into darkness and the moon to blood before the coming of the great day of the Lord. So, how soon will that be? Well, I don't know. Depends on how fast the atmosphere changes, but it seems to be changing very quickly. Thanks very much. My name is Lee, and I'm a Christian.